Okay, in this last page of lesson 15, we're going to take a look at the concept of domain and range. We already said what the domain was. The domain is basically the set of all inputs. So let me write that down here. So the domain is the set of all inputs. The codomain, if you remember when we defined that, that was the set of all possible inputs. But the range, which is now the new concept, is a set of all actual outputs. Right, so the codomain is a set of all possible outputs. The range is a set of all actual outputs. So the domain, the codomain could be bigger than the range because there could be elements in the codomain that are not used. Everything in the range is used, so it could be smaller. Now visually from the graph, it is relatively easy to figure out what the domain and the range are. It is just basically the wideness of the graph, either horizontally or vertically, with one caveat that I will just explain at the end. But that is it, basically the horizontal span. So let's start looking at this one. So the domain of this, the domain is a horizontal span because the domain is a set of all inputs. The inputs are the x's, the outputs are the y's. So we have to look at the x's. So it is a horizontal span of the graph. So the graph is sandwiched between what and what? Well, in this case, the very first example here, this graph has, you see, it has an arrow. That's supposed to mean that it goes on forever in this direction. So that means to the left, it just goes all the way to the left forever, right? So that means to the left, it goes all the way to minus infinity. It keeps going and going and going. So all the way to minus infinity. On the right, though, there is a dot right here. There's not an arrow, so that means that's where the graph stops. So then, if you look at that, that is a 5. So that means the graph actually stops at 5. And that is the vertical, I mean the horizontal span. It goes from minus infinity, it goes all the way to the left, keeps going and going, and then to the right, when you move to the right on the graph, you stop right at 5. And because the dot is filled in, it should be bracket. If it was a hollow dot, then it would be a parentheses, but it's included, so it should be bracket. Okay, so that is the domain. So we're gonna do all the domain ones, and then we're gonna talk about the range, which is basically the same thing, but the vertically, looking at it from the Y perspective. Okay, the domain of this one. So look at this graph. That graph is starts right there. There's a dot, not an arrow. So there's a dot right there. It is hollow dot. It is not filled in. So that means that point, even though it starts there, it's not included. So it's going to be a parenthesis. But the graph is sandwiched between, right, the graph starts right there and ends right there. So that is the horizontal span of the graph. That is the domain. So the domain of this graph is going to be the graph starts at -5, it's not included, so -5, and then all the way to -2. So it's going to be from -5 to -2. And again, parentheses because neither of those is included. And that's the domain of that. Now let's take a look at this one. What do you think will be the domain of that one? There's an arrow right here. So that means keeps going forever to the right. And there's a hollow dot right there. So that's where it starts. So it starts here. right there, and it never stops. It keeps moving to the right. So that means the domain of this one is going to be starts at -4, not included, there's a hollow dot, and then it goes on forever to the right. So -4 to infinity is the domain of that one. Okay, now let's look at this one. What is the domain of this one right here? Okay, there's a dot right here and there's an arrow right here. So that means when you look at it from the x perspective, right, horizontal perspective, it keeps moving all the way to the left forever, right? It keeps moving to the left. So that means it's gonna go to minus infinity from the left. It never stops, it keeps going to the left forever. So from minus infinity. And then the when you look at it to the right, the graph never passes this point right here. That is the furthest it goes on the right. So that means it stops right at 3. And then there's another hollow dot there, so you must include it. So that should be bracket. So the domain should be from minus infinity to 3, because when you go, the graph keeps going to the left forever, but the furthest it goes on the right side is at most 3. It never gets past that point right there. So up to 3. Okay. How about this one? The domain of that, the horizontal span, the graph is sandwiched between these two numbers, these two vertical lines. That's it. The entirety of the graph is there between this and that. So that means the domain is between -4 and 3. Between -4 and 3. That's the domain. The -4 is not included. There's a hollow dot right there. So you write from -4, and then the 3 that is filled in, that is included. So you write -4 to 3. And that would be the domain of that. Okay, and here's the last one. What is the domain of this one? This one has a dot right there and an arrow there. What do you think the domain of that one will be? Okay, the domain of this one is, so you start at 4, right? That is your starting point. You start at 4, but you keep going to the right forever. So that means you start at that's -4. I should have said -4. I don't know if I said -4 or 4. -4. So you start at -4, that is included, and then you keep going to the right forever. -4 to infinity. And that is the domain. That's how you find the domain. Now, the range is exactly the same concept, but from the point of view of y, like is the vertical span of the graph. Okay, starting with this one, this graph goes down forever, goes down forever. So you go down all the way to minus infinity. It goes down forever. And then the highest it reaches is right there, is +2. Sorry, yeah, that's a 2. So you go from minus infinity all the way, the highest you attain is 2. So that means the range of this one is from minus infinity to 2. And remember that this one is filled in, so that means the 2 should be included. Minus infinity to 2. That is the vertical span of that graph. The highest it reaches is 2, and it goes all the way down to minus infinity. Minus infinity to 2. Okay, let's look at this one. What is the range of this one? Well, remember, we're looking at it from the point of view vertical. The graph is sandwiched between what 2 points? The highest it reaches is right here. The lowest it reaches is right here. So the entire graph is contained between those two horizontal lines. So the entire graph is sandwiched between 4 from above and -4 from below. The entire graph is there, so that means the range is from -4 to 4. And that is it. -4 to 4. Both are hollow dots, none of them is included. So that is the range of that one. Okay, what do you think will be the range of this one? Okay, the lowest point on the graph is this right there. See the dot right there? That is the lowest point on the graph, and then it keeps going up forever. So that means the lowest point is, remember that is a y perspective, so that should be a -1. It is not included because it's a hollow dot. From -1, and you keep going up forever. So to infinity. Okay, now let's look at this one. Okay, the range for this one, you see how that arrow is going left and up, so it's going like that. So that means it keeps going up forever. It keeps going up, I mean also to the left, but up forever. So that means from above there's no ceiling, it keeps going up. So it goes all the way to infinity. And from below, the lowest point it attains is this one right here. It is -2. So the entire graph is sandwiched from below between -2, and from above there's no ceiling, so it's plus infinity. So that means the range will be from -2 to positive infinity. Now that one is filled in, so that means you should use a bracket. So this one is bracket from -2 to plus infinity. The lowest it reaches is -2, and then the highest, well, there's no bound for that. It goes all up forever, so to infinity. Okay, how about this one? What do you think will be the range for that graph right there? Okay, let's think about it. So the graph, the lowest point it reaches is right there. There's a hollow dot, that's where the graph starts. The lowest point it reaches is there, and the highest point it reaches is there. The entire graph is sandwiched between 5 from below, -5, -5 from below, and then from above is a 2. So that means the range is between -5 and 2. Now the -5 is not included because that's a hollow dot. And then the highest point, this one, there's not a hollow dot there, so I mean it has to be included. Even though it's not like a big dot, if it's not specifically drawn like a hollow dot, that means it's included. So The highest point is 2, so bracket. So that's the range of that one. How about this one? What is the range of that one? Think of the lowest point and the highest point. That's when you think about the range, that's all you have to think about all the time. The lowest point and the highest point. And remember, it has to be from the y perspective, is the y coordinate. So that point right there is the lowest point, but from the y coordinate perspective, that's a 0, not a -4. Okay, from the x perspective is -4, but from the y perspective, which is what we need to think of when we're thinking about the range, is a 0. So that means this is 0, and then the highest it goes, well, it goes up forever, so plus infinity. All right, so that's how you find domain and ranges. Domain is the x perspective, so uh, the, it is the horizontal span of the graph. So you have to look at what is the further to the left it goes, what is the further to the right it goes. And then the range is a vertical span, so it will be what is the lowest it reaches and what is the highest it reaches. And that's it. Uh, Now there there is a different there are some circumstances in which the graph could be broken. If you look at all these examples, all of them, well, there's no gaps in the graph. So the graphs are not broken, but it could happen that a graph is broken. So you could have something like this. So this is the caveat that I said, that is uh, it is the vertical span or the horizontal span, but if the graph is broken, then that could change things a little bit. So let's do this example. So this one, let's start by trying to find out what is the domain. The domain of this one, it is the horizontal span. So the graph is sandwiched between, so let me see, this is a -4, -1, -2, -3, -4. And then this one is 1, 2, 3, 4, 5. Okay. The entire graph is sandwiched between -4 and 5. Okay, and there's no gaps in between these. So if you imagine that you could move this up, it would be like a continuous curve. If you could move this up, right up to here, you see that there would be no horizontal gaps whatsoever. So the domain of this one is actually from -4, that's included, all the way to 5, and that's also included. You could also do this piece by piece. So you could just do this piece and then forget about that piece. And then from here to here, it would be from -4 to 0. And then because you're doing it in two pieces, you have to say union. And then this one will go from 0 to 5. From 0 to 5. But if you notice, this one says you need to include 0. And this one says don't include it, but you're doing the union. So that means you're putting them together. So you're including 0 from this side. So if you're including 0 from that side, that means 0 is included. So actually all numbers between -4 and 5 are included. So that's why these two things are the same. Things are the same, you use the most compact form. You just write that. That is a domain from -4 to 5. There's no gaps. There's nothing is missing. Now I'm going to give another example so this might become clearer in the other one. Now let's look at the range. The range is the vertical span. So the graph is sandwiched between these two. Okay, so it would be, what is that? One, two, three, four, five, six, seven. 7, and then 1, 2, 3, 4, 5, 6, 7. -7. Okay, so the entire graph is sandwiched between -7 and 7. But if you look at that, not all numbers between -7 and 7 are used because there's no graph in this whole piece. If you look at it, there are no numbers here. I mean, not no numbers, no part of the graph is here. This part has, this section right here does not contain any part of the graph at all. So that means these numbers should not be used as part of the range. They're not part of the range because there's no piece of the graph in there. It's completely empty, devoid of any piece of the graph. So that means they should not be part of the graph of the range. They should not be part of the range. They have to be excluded. So that means that the range should be only between 7 and 2 because that's where there's a part of the graph. And then between 1, 2, 3, 4, between -4 and -7 because there's a part of the graph in there. These numbers between -4 and 2 should not be used. So that means when you write down the graph, you basically do it in two pieces. When you write the range of the graph, you're doing it in two pieces. You say from 2 to 7, and I'm writing that on the right because we usually write negative numbers on the left. And then from -7 to -4, -7 to -4. And now, you see I included the -4, that's wrong. You should not include the -4 because there's a hollow dot there. So let's make that correction real quick. That should be a parenthesis. So that is the answer. Okay, let's do one more of that. Here I have another one. Let's find the domain and the range of this. Okay, so this one is 1, 2, 3, -1, 1, 2, 3, 4, 5, -5. And this is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Let's start with the domain. The domain is a horizontal span between left and right. The entire graph is sandwiched between -5 and 8. However, not all numbers are used because there's a gap in there. You see? There's no graph at all in this section. No part of the graph is in this section. So that means we should not be using those numbers as part of the domain. They're not part of the domain. So that means then we have to use the numbers between -5 and 0 and the numbers between 4 and 8. Because those are the pieces where there's a graph, a part of the graph. So that means the domain is going to be from -5 to 3. Don't include the 3 because there's a hollow dot there. Sorry, my bad. To 0. That should be a 0. Because I'm looking at it from the x perspective. From the x perspective, you go from -5 to 0. The 3 is for the y perspective. So from -5 to 0, and then from 4 to 8. So union 4 to 8. Okay, so that is the domain. Now for the range, the graph is sandwiched between 4, 5, 6, 6, and -2. So the graph is sandwiched between -2 and 6. The entire graph is sandwiched between -2 and 6. However, there's a piece right here. There's an interval where there's no graph at all. Oops, it keeps like wobbling. Okay. You see that there in that section there's no piece of the graph at all. So we cannot include that. So that's going to be not included. So we're going to say the range is from -2 to here. So basically we're leaving out this section because there's no piece of the graph in there. So from -2 to 1, from -2 to 1, both are included. And then we leave this out and we go from 3 to 6. Union from 3 is not included, to 6. Okay, and that is the range of that one. So there are some examples like this on the actual homework where there are gaps. Okay, so you have to, you're going to have some answers that look like that, that are unions. Okay, and the last part is how to find the domain and the range when the function is described in terms of points, like this one. These are points. Okay. So now, when you have the coordinates of the points, finding the domain is really easy. The domain is the x's, like the x values. That means the first coordinate, and the range is just the y values, which is the second coordinate. So this is going to be easy because then the domain is like the x's, right? The first coordinate. So you write all the first coordinates, write them down. The first coordinate is 3, 5, 1, 9, and 3. 3, 5, 1, 9, and 3. Now this is a set, so really repetition is not needed. You don't have to write the 3 twice. And also we normally write them in order. So the better answer would be 1, 3, 5, 9. That's better. We don't use repetitions when we write sets. And we normally write numbers in order as usual. So that is the domain. For the range is just write down the y coordinates, the second coordinates. So that's going to be 2, 7, 4, 2 already. You see there's another 2. I already wrote that, so I'm not going to write it again. And then 7 again. But I already wrote 7, so I'm not going to write it again. So that's it. 2, 7, 4. And then if you want, normally we write this in order. So 2, 4, 7 looks slightly better. That would be the range. And let me zoom out there. Okay. And lastly, the second one, what is the domain? Again, it's just the x coordinate, so that means the first coordinate. The domain of this one is going to be 0, oops, 0, 3, 8, 2, and then 3, but I already wrote 3, so I don't have to write it again. And normally we would prefer to write it in order. So 0, 2, 3, 8 is better. I mean, this is not wrong, but this is better. It's in order. And then the range is the second coordinates, the y coordinates. So it's going to be 2, 3, 7, 2. I already wrote it down, so I don't have to write it again. And then 9. And that's how you find the range if the function is given like this as a list of points. That's it.